This final 7.2 video is brought to you by Lego Rescue. That's some old school town stuff. I think this guy was the diver. So here goes. The last one is half angle identities. Here we're just going to throw them right at you. There's proofs out there of where they come from if you'd like. So this is very similar to that sum and difference angle kind of thing. How we use it is if we can cut an angle in half or double an angle and use a unit circle angle, we can get exact values. The one catch here, as noted, is you have to be aware of the quadrant to determine which of these two options should it be, a positive number or a negative number, since we're probably going to be using reference angles. So here they all are: tangent, sine, cosine. Notice tangent has 3 different options for it. So we want to find the exact value of tangent of 22.5. First note that 45 degrees divided by 2 is equal to 22.5, and this is a unit circle, special unit circle angle. So what we're going to say is that tangent of 22.5 degrees is really equal to tangent of 45 degrees divided by 2, and now we're set to pick whichever one of these we want. Do we want to have a square root to mess with, or do we want to not have a square root to mess with? It doesn't particularly matter. And then the other question is, do we want to have a sum in our denominator, or do we not? So I'm gonna pick this last representation of the half angle value so that I just have one thing in the denominator. So we're going to have 1 minus cosine of what we're dividing by 2, whatever that angle is. In this case, it's 45 degrees, divided by sine of 45 degrees. Let's quick dip into our memory banks of our unit circle. Where's the 45 degree angle? It is here, halfway between 0 and 90 degrees, and the ordered pair associated with that angle is root 2 over 2. Note, by the way, that 22 degrees, 22.5, is in quadrant 1. So whatever our results are, we don't have to worry about the angles or anything. All right, that means we can rewrite this expression we have here as 1 minus the square root of 2 over 2 divided by the square root of 2 over 2. How wonderful. Okay, so here comes algebra, everyone's favorite thing in the world. Do you remember how to add fractions? Yes, you do. You need a common denominator, right? So we're going to multiply the 1 by 2 over 2, so these become common. That gives us 2 minus the square root of 2 over 2 in the numerator, and then all divided by root 2 over 2. And then I have to ask, do you remember how to divide by fractions? And of course you're like, yes, really division isn't a thing. Division is just multiplication by the reciprocal. So this becomes 2 minus the square root of 2 divided by 2 times the denominator flipped, 2 over root 2. All right, well, 2 divided by 2 is 1, last I checked. So we get 2 minus the square root of 2 over 2. I am perfectly happy with this answer. I'm most certain that my math lab will not be happy with that, because our textbook is kind of default notion is rationalize everything. No square roots in the denominator. It doesn't particularly matter. It depends on your professor. I had a professor, my Calc 1 professor preferred rationalized answers. My Calc 2 could care less. In fact, yeah, they said don't rationalize. So you need to know how to do it, because you never know what you're going to face. So I'm going to multiply by root 2 over 2. That will rationalize the denominator. I chose this number 1 by noting the denominator there. Again, be careful with your distributive property. So our numerator becomes 2 square roots of 2 minus, get ready for this, root 2 times root 2 is 2. And then our denominator is just 2. Oh, look at that. We can factor out a 2, so that's square root of 2 minus 1 divided by 2. And unlike those previous problems I did, this is actually useful because we can note that 2 divided by 2 again is 1. So our final answer is the square root of 2 minus 1. Now, we could have picked any of these other representations, and we would have eventually gotten to this solution. It just might have been, the algebra would have been different, the expression we were simplifying. All right, so, another one. Find the exact value of tangent of 5 pi twelfths. So we want to find some x divided by 2 that equals 5 pi twelfths, and preferably that x needs to be a unit circle. Well, we can't force it. We just have to hope this comes out to be that. So let's solve for x. Well, x equals, multiply both sides by 2. Shoop, shoop. 1 times 2 over 1, bam. 2 times 2 that's 10 pi twelfths. Oh, wonderful, right? Because that's 5 pi 6. That is a unit circle value. Note that this is also a first quadrant angle. I know that because 6 pi twelfths is pi halves, which would be up in this joint. Oh, wait a minute. Yeah, so this is a first quadrant angle, but this is a second quadrant angle. So we need to be careful with our results. All right, note what we've done here. We've taken tangent of 5 pi twelfths and said that's the same thing as tangent of 5 pi sixths divided by 2. They're the same expression. Well, that means, well, now we're going to pick one of these things to do. And boy, do I want to be a jerk and pick this one? Yes, I want to be a jerk and pick this one. I'm going to pick this one. No, I'm going to... yeah, let's do the square root one. Okay, so we know that this is equal to plus or minus the square root of 1 minus cosine of 5 pi sixths divided by 1 plus cosine of 5 pi sixths. Now, you at home might be wishing I had picked one of the other two, this one or this one, and I applaud you and say you do those and see if you can't get the same thing as I've gotten. Okay, we need to figure out what is 5 pi sixths, what is cosine of 5 pi sixths to be precise, in our unit circle. So let's rely on our memories. Here's the unit circle. 5 pi sixths is going to be right here. Pi 6 would have been here, and we've just gone all the way over here to get 5 pi 6. Why don't I write that? If you recall what this one is, that's the square root of 3 over 2 comma 1/2. By the way I know that is we have the longest length on the x-axis, and this is the longest value in our special values. So when we get over on into quadrant 2, we know that the x values are negative and the y values are still positive. So we've got what we need. We can now rewrite this thing. This becomes plus or minus the square root of 1 minus a negative root 3 over 2 divided by 1 plus a negative square root of 3 over 2. Note we're picking this x value for cosine of 5 pi sixths. All right, we're off to the races now. This is going to be fun. So, I need lots of space. So I'm going to just draw a little line here, and I'm going to simplify things over here. We'll do plus or minus, we'll do square root, and it's going to be 1 plus the square root of 3 over 2, all divided by 1 minus the square root of 3 over 2, and the square root of all that. All right, I've just created a worse problem. I really shouldn't have picked this one because this is going to require us to simplify a complex fraction like we did back in 139. But isn't that great review? So I'm going to go ahead and note that this 1 over 1 is really 2 over 2. And this 1 over 1 can really be written as 2 over 2 so that I can combine the fractions. And so this numerator is going to become 2 plus the square root of 3 over 2. And this denominator is 2 minus the square root of 3 over 2. And then we're still interested in the positive or negative, one of those two options, square root of all that. Well, next step is what I set up here. When we have an a divided by b, a division isn't really a thing. It's just multiplication by the reciprocal. So this becomes plus or minus the square root of 2 plus the square root of 3 over 2 times 2 over 2 minus the square root of 3. Man, I really regret picking this one. So these two simplify. Shazam, they're gone. They become 1. 2 divided by 2 is 1. And we're left with plus or minus the square root of 2 plus the square root of 3 over 2 minus the square root of 3. Yowza. So here comes some really complicated rationalizing, because we have to rationalize this denominator, and then we can rationalize the whole thing, and then we'll deal with the plus or minus. So to rationalize, we multiply by the conjugate of the denominator to get rid of that radical down there. Okay. Note we're doing this within the radical, right? So the numerator, notice it's 2 plus the square root of 3 times 2 plus the square root of 3. That's just 2 plus the square root of 3 squared. And the denominator is going to be 2 times 2, which is 4. Note the inner terms will disappear, and so then it's going to be minus the square root of 3 squared, which is what? 3. And 4 minus 3 is 1. How simple is that? So this is plus or minus all that, which, boy, I did this really poorly. When we simplify this, we're going to take the square root of the top one, and that top value is this. And when we take the square root of 1, we get 1. So this is our result. 2 plus the square root of 3. All we have to do is figure out, is it a plus or minus? Well, let's go back. Since we're in the first quadrant, all of our values are positive, so it has to be the positive one. Final answer is 2 plus the square root of 3. Whew! That's one for the history books.